In this question, we will be looking to solve for the height change in the fluid as a result of the acceleration of the tractor and trailer and the pressures present in the fluid. As you can see in the diagram, a tractor is connected to a trailer of length 10 meters filled with water to a height of 1 meter. We can imagine the width of the trailer to be 1 meter as well, so that the question is satisfied and the trailer can hold 10,000 litres. The capacity is easily calculated by multiplying the length by the height by the width, and we know that 1 meter cubed is equal to 1,000 litres. It's important to note that the height of the trailer is unknown, labelled h, because we have to solve for the height change due to the fluid motion as a result of the acceleration. So from the question, the trailer is open to the atmosphere and starts off from rest, so the acceleration is 0. We can see that the isobars, which indicate points of equal pressure, are all horizontal when the trailer is not accelerating in the x-axis direction, and the equation atmospheric pressure plus the density of the fluid multiplied by the acceleration due to gravity multiplied by the height of the fluid gives the pressure at any point in the container. Now when the trailer begins linearly accelerating, there is fluid motion in the y-axis direction, and the isobars slope at an angle theta. To find the height change in the fluid, we want to find this angle theta and use our trigonometric function tan to solve for it. Now, finding the pressure of a certain point in this case is slightly more difficult, as we have to calculate the horizontal distance x and the height of the water above the point, which is more tedious to work out due to the variable height of the slope. The equation below is used to find out the pressure at a point, which is similar to the previous case, but where ax is the acceleration in the x direction and x is the distance from the left-hand wall of the container. Now we're looking to solve for the height change, but first we need to find the angle theta. So how do we go about that? Well, let's imagine pressure at a point P in the container. We know that the pressure in the x direction is equal to rho times acceleration times x, the distance we are away from the left-hand side of the container. But because the container is open, that pressure will act in all directions and will push the water up. So now we know that the pressure in the x direction must equal to the pressure in the y direction above it, which is equal to density times g times h. So we let them equal each other, cancel the densities, and rearrange for h. Then we get this equation for the height. You might be wondering, I thought we were looking for theta. Well, you might notice that it's looking a bit like the slope of a line equation, y equals mx plus c. And the slope is acceleration over gravity, which makes sense, because the greater the acceleration, the greater the slope of the fluid will be in the container. We can let this equal tan theta and solve. Viewing our diagram in the top right corner, we can see that h is the rise and the run is 5 meters. This allows us to calculate the increase in the height of the fluid h. So the total height of the trailer should be at least 1.51 meters, so that no water is spilled when it accelerates linearly at 1 meter per second squared on a flat surface. To find the pressure at a point P in the container, we want to use our equation mentioned earlier, and we sub in our values and we get an answer of 111,298.2 pascals.